In part A, the temperature is 10 degrees Celsius, the mass is 8 times 10 to the negative 5th grams, and the volume is 100 milliliters of water. The first part only asks for the dissociation of silver chloride in water. The equation is simply the silver chloride broken down into its constituent ions, silver plus 1 and chlorine negative 1. The second part asks us to calculate the solubility of the silver chloride. In order to do that, we take the mass of the silver chloride and divide it by its molar mass, 143.32, to get 6.2 times 10 to the negative 6 moles in 100 milliliters of water. Using dimensional analysis, that comes out to be 6.2 times 10 to the negative 6 moles per liter. In part 3, we have to calculate the KSP of silver chloride by multiplying the concentrations of the constituent ions, which are the same as the concentration of the silver chloride calculated in the last part. We get the solubility product constant 3.8 times 10 to the negative 11. Part B gives us a temperature of 25 degrees Celsius, a KSP for lead 2 chloride of 1.6 times 10 to the negative 5th, and a KSP for silver chloride of 1.8 times 10 to the negative 10th. To solve part 1, we need to calculate the molarity of both the chlorine ions and the lead 2 ions. First we get by multiplying the volume and molarity of the sodium chloride solution and then dividing it by the combined volume of both solutions. We perform the same steps for the concentration of lead 2 ions. We get 0.02 moles per liter and 0.015 moles per liter respectively. Calculating for Q, we get 6.0 times 10 to the negative 6. Since the Q is less than the KSP of lead 2 chloride, no precipitate forms. Part 2 asks for the equilibrium value of the lead 2 ions. Using the information given, we take the KSP of lead chloride, 1.6 times 10 to the negative 5th, divide it by the concentration of chlorine ions, added raised to its coefficient, which comes out to be 0.25 to the second. The answer is 2.6 times 10 to the negative 4 moles per liter.